Okay, so let's just do a few more exercises that have to do with both of the objectives here. Might be some real number stuff, might be approximating square root. And that's what this question is. And yeah, it's multiple choice, and I usually can't stand them, but this is like, maybe it's from, definitely not SAT because they have 5 answer choices, but it might be like an ACT or some sort of end-of-course kind of question. Putting these numbers in order, and notice that like every single one of them have the same numbers, so you don't have to deal with 4 different sets of numbers each time. That's good. In the decimal part, that's going to be pretty easy. The only thing is that we have that square root of 7 in there. Okay, so let's just approximate the square root of 7 again. So the square root of 7, I know square root of 7 is in between, I got square root of 4, and square root of 9. Square root of 4 and square root of 9, yep. It's in between 3 and 4. Bad math, bad math, bad math. Well, I need to erase that one too. In between 2 and 3, yes. And then as far as making the little fraction thing goes, that's 3 spaces, and this is 5 spaces. So we're talking 2 and 3/5, which is 2.6. So we'll say that's about 2.6 for that square root of 7. So in terms of like increasing, the smallest number on the left and the negative numbers, the bigger the actual number it is, if it has a negative sign in front of it, the smaller the number is, right? So for example, if I talk about 10 and I talk about 1, negative 10 is much, much smaller than negative 1. Okay, yeah, that's easy stuff. So when I look at the numbers there, the negative 2, that's the one that's screaming out to me because of the negatives, negative, negative, negative. But the negative 2 is the biggest number, so it's actually the smallest negative number. And then 0.75 and 0.5. Look, I just happened to pick, I think, the right one. Let's just see. 1.5 and then the 2.6 for the square root. Oh, that was... Here, let me color it in because, oops. There it goes, standardize this. Don't use that as an example on how to color it in on your test form because I don't think that will work. Okay, so here is an SAT question. I try to, as much as I can, throw in an SAT question every once in a while, so this is an actual one. If x represents the sum of the 10 greatest negative integers and y represents the sum of the least positive integers, which of the following must be true? And so first of all, this is a great example of a kind of SAT question where you're going, what? Really? They're asking me a question like that? And the other thing is that this is one of those Roman numeral answer choice ones where you have 1, 2, and 3, and then you have to pick the combination of those 3 things that are always true. Or maybe they're always false or whatever the question might ask. And so you have something like 1 only, 2 only, 1, 2, 1, 2, 3. Something like that. So if x is the sum of the 10 greatest negative integers, so let's just think about that. X, this big X, this is the 10 biggest negative numbers, so integers. So what's the biggest negative number you know? It's negative 1, right? Biggest as in, well, negative 1 is way, way smaller than all of the rest of them. And so then you have plus negative 2 plus negative 3 plus ... plus negative 10. Right? Does that make sense? And then y would be the sum of the least positive integers. So what is the smallest positive integer? It's 1. And then we got 2 plus 3 plus ... plus 10. Not 110. Well, what? 10. Okay. So now let's make sense of these Roman numeral answer choices. 1, x plus y is less than 0. So if I added these two up, look, if I added them up, what would happen to each one of those numbers? They would cancel out. It would be equal to 0. It wouldn't be less than 0. It would be equal to 0. So that part is wrong. So I'd cross that one out. Now, if I'm taking the SAT, I would actually stop right there and I'd look down below, and if anything had the number 1 in it, I'd cross it out. Sometimes sometimes that's enough to answer the question. You don't even have to do the rest of it. Anyway, what if I take y, this is number 2, y minus x? Do I get 2 times y? So let's think about this. If I take all of this set of numbers and I subtract out all of the values in x, will I get 2 times as much as y? And the answer to that is yes, and here's the reason why. When I go 1 minus a negative 1, it's actually 1 plus 1, right? 2 minus a negative 2 is actually 2 plus 2, right? Do you see how every single one of those subtraction problems is going to turn into a plus, and you've just doubled up all your numbers? So that is correct. Okay. And then finally, is x squared equal to y squared? And this one is also yes. And the reason why is because these will have the exact same absolute value. One is going to be positive and one of them is going to be negative. But when you square them, they both become positive again. And so, yeah, that one works out too. So whenever I would write this down, or whenever I'd look for the answer choices, I'd look for the one that said 2 and 3 only. Okay. This is going to conclude. This is going to wrap the whole thing up. Like we've been talking about real numbers. So the question is, a natural question here is, are all numbers real? And well, here, let me just lead you into that. Let's look at this equation. It's a quadratic, very, very simple quadratic equation. Quadratic means that it has a squared in it, and we're going to try to solve it for x. Okay, so like algebra, blah, x squared plus 1 equals 0. I want to get x by itself. So okay, so let's subtract 1 over. X squared equals negative 1, and I can stop right there. Because what this is saying is I'm trying to take a number, x, and I'm squaring it, times it by itself, and I get an answer of negative 1. So just think about it for a second. What number can you square, multiply times itself, and get negative 1? How about 1? 1 times 1 is 1. That won't work. How about negative 1? Negative 1 times negative 1 is, no, that's positive 1. So no, that doesn't work. The answer is there is no real number that you can square to get negative 1. What we usually write actually is x is the square root of negative 1. And this is not real. Not real. And we call that number an imaginary number. Now this lesson is not about that, but I'm just giving you a perspective here. And we will talk about imaginary numbers this year. And it may be this, like right here, might be your first exposure to it. Now, the terminology, though, is, I don't know, kind of cheeky, because people would want to confuse it with like the actual definitions of what's real and imaginary, right? As in something I can touch and something I can't touch. But that's not really the case for real and imaginary numbers. Just because they're called imaginary doesn't mean that they do not exist, okay? Because they do, right there. I just showed you where it comes from. Okay, so found this comic online, of course, and so here's the number 8, and he's talking to some of his other number friends, and he goes, "Hey, you guys want to meet my new friend?" And they're like, "Sure, but where is he?" And 8's like, "Well, he's right here." And he turns, but they can't see him. Like, why can't anyone else see you? And the square root of negative 1's like, "Well, it beats me." Why? Because he's imaginary. Yeah, so if a number is an imaginary number, it's part of these things called the complex numbers. Set of complex numbers, it has its own letter. It's a C, complex C. And to totally confuse you, it's not just the imaginary ones, it's the real ones. All real numbers are part of this set too. So definitely more on this later. Do not worry your pretty little head over the complex and imaginary numbers just yet. Just kind of giving you some extra detail on this lesson. Okay. So this wraps up your first lesson here on real numbers, being able to describe real numbers and all of their subsets. You can see this in this little chart right here. You got real numbers up top. That's all this is about, right? Just the real numbers. And it comes in two flavors. We have our rational ones and our irrational ones. Oh, but hey, those rational ones, we could break that up even more. We've got integers, and then we've got the numbers that they're rational. Like I can write them as a fraction, but they're not whole numbers, okay? And then the integers, I can break that up even more, and so on. So we have negatives and positives, and within the positive integers, I've got natural numbers and whole numbers. Okay, so when I'm talking about the assignment, which I'll talk about in just a second, this is another example of a graphic, a kind of thing that you could do to represent the set of real numbers. And then we also learn to approximate square roots to nearest 10 without using a calculator, just all in our brains. Just understanding the pattern or some kind of pattern about real numbers. Okay, so there's Rowan. So that's how come you get to see Rowan. You'll throughout all of these videos, you might actually get to see real Rowan. But yeah, there he is, talking about your assignment there, telling you that he loves math for reals. I don't know if that's true or not yet. I mean, what he likes right now is like Star Wars and dinosaurs and stuff. So yeah, anyway, so there's your assignments. See you in class.